Alright, hey. So I'm going to be teaching y'all how to find the differential of an equation today. So starting out with the definition, a differential is like you'll use this whenever like you're given an equation such as y equals f of x. So given that, you're able to determine that dy and dx, so it's like the derivative in respect to each of those, are the differentials. And using that in mind, you can formulate the equation that dy equals f prime of x times d of x. So this should look pretty familiar to you from using derivatives, as it's saying the derivative of y equals f prime of x, which is the derivative of that, times d of x. So it's basically nothing different than like finding the slope of the tangent line and everything, because that's exactly what you would do with a derivative. So essentially you're finding the derivative and then you're adding on the second differential form, which is going to be d of x. And then looking at our first example right here, so you can see that our equation is going to be y equals x squared times sine of 2x. So you should know right off the bat that you're going to need to use the product rule, and you should know that from our derivative practice. So using the f and g right here, you can determine that your first function f is x squared, and then your second function g is sine of 2x. So that's this right here, and then the little second part, that's where I got those two from. And then f prime is 2x, and then g prime, and you got to use the chain rule for that, so it's 2 cosine of 2x. So then cross multiplying those, and then adding them up together, you're going to get 2x times the sine of 2x plus 2x squared cosine of 2x. And so I put those whole thing in brackets just to make it noticeable that you're multiplying that dx times the entire equation. It's not just the last term or anything, so it's really important that you include brackets or parentheses or something around your entire derivative answer, or else you could get points off for that. So differentials, they're not just used for like finding the derivative equations or something. They're also going to be really helpful whenever taking into account estimating errors, approximating errors, finding like the actual error and the estimated error, so like percentage, all that. So alright, so right there I have the estimating errors section of it. So this is an equation that you might see often, so it's saying delta y, so the change in y, is equal to f of x plus delta x, so the change in x, minus f of x. And so whenever you're looking at that equation, you want to keep in mind that the first section right there, that's going to be your exact, so your approximate guess or anything, and then the second one is going to be the error. So you might see that in like a ball and bearing type problem or anything where you have something that's changing, so it's going to be like your radius is changing from 12 to 13 or anything like that, of like a wheel or something, and so you want to find like the percentage that the area changed with that change in radius. So anytime you have any problems like that, it's going to be like estimating error problems, approximating error problems, you're going to need to be able to use this, and you're going to need to put into practice your differential equation. So it's really not that hard, nothing to stress over, just taking the derivative of a function and then remembering to multiply that dx times the entire thing. So I hope that you learned what a differential is and some of the uses that you're going to see in this unit for it. So thank you.